Let's start. Thank you very much for being here with us today. This session will be about the IP audio client new features. I am Davide Nossa, your host during this webinar, this training, and I will be glad to walk you through the recently introduced features in the version 2.9 of the firmware, which makes of IP audio client a supercharged device, as we can see from the first slide right here. So, I'm very sorry that Patrick cannot do this introduction. He is much better than me in doing this, so I hope he's fine anyway. The way it will work out, we will do the presentation, the webinar. I will explain you the functionalities, and at the end, we can have a Q&A in case you have any question about what we will discuss. The agenda looks like what you see right now on the screen. We will have a small introduction on the IPAC family. We will just a bit of a refresh on who are the members of the IPAC family. And then we will go straight into the functionalities, starting from the scheduler, the RTP Forwarding, Equalizer, the REST API, and going back into some use cases where IPAC can be very useful. Closing with on where to find information related to the faced topics during the webinar. So without any further ado, let's start with the IPAC family. A bit of a refresh. These are the three devices that today are part of the IPAC family. And first of all, IPAC means IP audio client, and it is the name of the firmware running on each one of the devices that you see right now on the screen. IPAC is an application, basically, in the firmware, and it is programmed in a way that it configures itself, its functionalities, what it exposes in the configuration, according on the hardware unit on which it is running. So, depending on the hardware resources available, IPAC offers or doesn't offer the functionalities exposed in the web configuration interface. An example is the Extremer M400 and the MPA400 offers two USB ports in the front panel, and you have automatically on the firmware the possibility to use the USB ports to play back music. Something that doesn't happen on the IP firmware because there is no USB port. So these allow us to be very flexible with the new functions that are introduced for any hardware on which IPAC will run. The three devices, as I said, these ones are the Extremer M400 with the line level output on RCA connector, stereo, the MPA400, which offers an amplified output up to 40 watts, PoE capabilities, and also supporting the possibility to be externally powered. And this device drives directly loudspeakers. With his little brother, the IP Former TPA400, a bit less capable than the MPA400, up to 6 watts of amplified output on the same screw terminal block, and can drive as well loudspeakers. The MPA400 and the TPA400 are mono devices. They have a single output. What these devices have in common? The firmware, as we said, the IPAC firmware, so the IP audio client, which is at the core of every IPAC device. Just to refresh a bit, IP audio client is one of the most flexible firmware that we offer because of its multi-layer priority approach. And you see it right on the screen, where for each priority layer, we can assign a specific type of source. And the playback of the corresponding block follows the priority handling management that we assign to the configuration. This is to ensure that mass emergency notifications always play on top of background music, on top of SIP calls, on top of paging systems. Already in the previous version of the firmware, the version 2.8, we had an extensive amount of sources supported, which makes of IPAC one of the most flexible decoders out there in the market. But with the introduction of the new features that I am about to explain right now and that we introduced in the firmware version 2.9, IPAC has been even boosted more. So let's start with one of the most important features we added, which is the scheduler. Actually, this is not just a scheduler, it's not one scheduler, but we have 3 schedulers embedded in a single source. The 3 schedulers are the fixed time announcements, the rotation, and the playlist. Fixed time announcements is the perfect scheduler for simple announcements that has to be scheduled at a specified time over the course of the week. Simple as that. A clear example is to schedule bells for a school. Easy. Rotation. This type of schedule is made to play assets following a configurable pattern. So I can upload in my sequence multiple assets that will play back following the order depicted by the configuration. On top of that, I can set time windows for each day of the week where these assets will play following an interval in between them. So I can schedule asset number 1 to play at 8, and then after 30 minutes or configurable interval, I play the second one, the third one, and so on and so forth. The playlist, this is also implemented as a scheduler and is the possibility to group multiple music tracks, files, into playlists and then schedule their playback over the course of the week. This is targeting mainly background music. So instead of using a stream or instead of using USB or RTP, we can use the scheduled playlist method to have the background music. It is important to denote that this is seen as a single source on IPAC, and the scheduler has an intrinsic priorities handled by itself, meaning that if an announcement plays and there is a playlist playing back in the background, the announcement of course plays on top of the playlist, being either a fixed time or a rotation. But since I want to take this webinar a bit more interactive, I want to show you this feature in action right now. So I will switch now screen onto my TPA 400 device in my network. And the first thing you have to do when you want to configure your scheduler, well, it doesn't have to be necessarily the first thing. You have to configure the source, of course. So we remember that IPAC had up to 5 sources configurable. In the version 2.9, now we removed the noisy user interface and we added this fantastic button that allows you to configure only the sources that you actually need. So without having all of them already predefined. And to use the scheduler, you now have this scheduler source. Once you configure your scheduler source, you can configure also the scheduler itself. As I said, it doesn't have to be necessarily the first thing to do. You can also create first the scheduler and then create a source. It doesn't matter, the order. So straight into the fixed time. This is a clear example of a fixed time announcement where I have my bell file scheduled to play at a specific time. We can change it even after having created the announcement on these days. Simple as that. Scheduling a new announcement is as easy as clicking on this button. I can select files already preloaded before in the audio files section, or I can upload an audio file right into here, choosing it from my computer. I have an announcement, bell 1, open, and I can upload the file. I can add a brief description and configure the time when this file will play. So for example, I want to play it at 11 a.m. on Tuesday and Thursday. Save. And this is now scheduled. I can easily, if I have the same announcement to be played over the week, I can even copy and then just change the time on when this can play. This offers a bit more flexibility in the configuration. Once this is saved, so I have to click on save, the announcement will be played at the specified time. An important consideration is about time. So you see this warning right here is to make sure you configure your time of the device correctly. The time is explicitly outlined right here in the top bar of the product. And to configure it, you just click on this one, which is a link to the settings page, and it opens up the accordion of the time settings. How the time is handled in IPAC. IPAC basically comes with the possibility to connect and set its time using NTP. And these are the default servers contacted by the device. What you have to do is to make sure that the local time zone where the device is installed is correctly set. In this case, I'm setting this to Europe, Amsterdam. If NTP is not a possibility, is not present or is not available, you can still set the time manually using this function right here. And this will basically overwrite the set time by the device. Just be aware that when you set the time manually, because none of the IPAC devices has a real-time clock installed, the time will be reset at every reboot. So it will force you to reset basically the time every time the device powers up. For this reason, I always strongly suggest to have an NTP running, taking care of the time configuration. It can either be a local, it can also be a local NTP. So these fields are configurable and you can write an IP address in here. So like 192.168.3.45. This is valid. It's important that you have, of course, an NTP server at this address reachable. Going back to the scheduler. Second type of scheduler, rotation. This is targeting advertisement playback mainly, advertisement campaigns that you can easily create just by adding clips to the rotation, setting up their playback order, so which one comes first, which one is the second, and so on. And then configuring the weekly time frames. So on every day, you can say, this rotation will play starting on Monday at 8 a.m. up to 6 p.m. And in between the audio files played, there will be 30 minutes of time. I can say to restart my sequence on a daily basis. If I don't flag this, the sequence will pick up the next file in line that is supposed to play starting from the previous day. So it doesn't reset the sequence basically. If this is flagged, instead, it will start always from the first file of the sequence. Last, the playlist scheduler. And this is very much related to this section right here of the software. The audio files tab now offers the possibility to create playlists, as you notice. And creating a playlist means click on this button, give a name to the playlist, and you can add files to the playlist, either selecting files already uploaded or uploading new files right here. So I can select more files, open, and I can upload them. Now it takes a bit more time because these are music tracks, so I can click on cancel. I already have a playlist created. And I can see I have 13 files, and the total duration of the playlist is this. Now, shuffle means, do I have to follow a specific order of playback of my playlist or not? And this is configured by flagging this item, shuffle files. Otherwise, the order of playback respected is the one depicted in here. I can move files just by clicking on the arrows. Once your playlist is created, you save the configuration and you are ready to schedule your playlist. The schedule is very much similar to what we saw for other schedulers. You select the playlist and define the time frame and on which days this playlist has to play. If the duration of the playlist is less than the time frame configured, the playlist will continuously repeat itself. And if shuffle is enabled, the song will be played in a shuffle mode. So this is it about the scheduler. one word about the volumes. You see that the scheduler source now has two volumes, so we can treat differently the volume of the music and the volume of the announcements. These volumes are soft volumes that are applied in real time when I move the sliders. And now go back to the slides. This was the first major feature of the IPAC version 2.9. The second one is the RTP forwarding. Very interesting. Since we introduced the scheduler, we wondered ourselves, okay, now we have a unit capable of scheduling any sort of message, assets, playlist. So theoretically, one single unit can already cover an entire use case, for example, a retail store. But what if I have several other units in my installation? And this can be true if I'm using IP formers, where for each loudspeaker, I can have one single unit. So in the same installation, I may have tens of IP formers installed. How can I ensure that the scheduler will actually play on every device at the same time and I hear no delays between the units where I am in the room? You cannot configure a scheduler, an individual scheduler on each unit, uploading files on each unit. Well, that's a lot of time, first of all, and then you will never get the perfect synchronization among the devices. So for this reason, it's much better to have one IP former or one IPAC device forwarding its traffic, its audio, its main audio output to a target RTP destination. And an example on the screen right here is that this device is forwarding all the sources that it is currently playing and it is subscribing to that target destination. Other IP audio client devices are simple RTP endpoints. So they will have the RTP source configured to join the same group that is forwarded by the IPAC sending device. Important to note is that the device that it is forwarding the traffic, the audio, is also subscribing to the same multicast group to play it from itself. So basically it becomes a client of itself. This is to ensure that also its analog output is in sync with the other devices. A nice feature that we added in this RTP forwarding is the transcoding option. You can select a multiple codec types that will change the audio format of the sent of the forwarded stream. And then we have the selection of the playback mode between regular or low latency. But let me show you this on the device, which is clearer. So I go back again into my TPA 400. And to enable RTP forwarding, now I have my scheduler configured, okay? So I have my playlist running, my announcement scheduled, and so on. So I want to enable the RTP forwarding. This is the configuration of the RTP forwarding. This is the address that we saw in the example. And this is the transcoding feature. So we can change the audio codec format among PCM, MP3, G722, G711, ULO, and ALO. Currently I have MP3 set, and here is the playback mode. So the playback mode is the same functionality we have also in the RTP source in IPAC. And it affects basically the buffer capability on the device, where we have regular aiming for synchronization and having a bigger buffer to have a constant delay in place, and which is the same across multiple devices in the same installation. This ensures that synchronization is maintained regular into my installation. On the other hand, low latency targets for end-to-end delay to be as small as possible. So as soon as samples are received, they are played out as fast as possible. This doesn't ensure synchronization, but it ensures fast play out from the source to the destination device. So in this case, I'm using regular, and if I show you, sorry, I have to submit. Now it's enabled. So that means that in this moment, my device became the client of itself. So this TPA400 is joining this group to play whatever this device is playing. So it's playing in synchronization with other devices joining the same multicast group. And I can show you using the remote config tool. This is my system right here in my network. I have an M400 and MPA400, which are part of the same group, the same zone. I remind you that the remote config tool is particularly useful to configure fast multiple devices in the same installation, like what I did basically here. I just created two zones. One is called leader, the other is called follower. So it's easy to replicate the same settings on the follower devices. And as you can see, I have my scheduler running on the TPA400 and the other devices receiving the RTP stream on this, joining basically this group. So one device is sending, the other devices are receiving, and they are simple RTP endpoints in this case, playing in regular mode as well to keep the synchronization between all of the devices in the installation. An important thing about the RTP forwarding is that the leader device, so the sending device on which I have enabled the RTP forwarding feature, becomes also the volume controller of all the other devices joining the same multicast group. So when I change the volume right here, this is affected and reflected on other devices joining the same group. Same applies for the mute function, which, by the way, is also a feature we introduced into the 2.9 version of the firmware. Good. So let's move forward. Third major feature is the equalizer. And this is basically, I think, the most straightforward functionality. And it's an equalizer, 4-band parametric equalizer added into the device, into the software, where for each band, we allow the possibility to set up 3 different parameters, as you can see, the Q factor, the central frequency, and the gain. For those of you maybe not so skilled in equalizers, audio equalizers, the Q factor is the bandwidth that is affected by the adjustment of the central frequency. So I can increase or decrease the spectrum, the curve of frequencies affected by the modification. A lower Q factor means a higher bandwidth of frequencies affected. A smaller and higher Q factor is a narrower range of frequencies affected by the boost or the cut. So normally you use higher Q factors when you want to target a specific frequencies for fine tunes and adjustments. It's a source-based equalizer. That means you have it on every source, so you can tweak it in a different way for every source, because you may not want to use the same equalizer settings you have for a background music stream and for paging, or for another source, which can be any RTP source. So you can tweak the equalizer in a different way for different sources. Just be aware that the equalizer is not available for Informacast, Synapse, and SIP sources as of today. Let me show you on the sources tab basically our equalizer for the scheduler, but I can add also another source like Barix Radio. So Barix Radio, enable. Until I don't have the source enabled, the equalizer is not available, but now it becomes available. By default, the equalizer is off, so I can turn it on. And I can change basically the parameters. I can use the mouse like this, and find my desired configuration. The equalizer changes are applied in real time, just like the soft volume. So you can theoretically grab your iPad, going around the installation and change the frequencies to fine-tune specific sources in your playout system. Once the equalizer is configured, you can see the icon becomes green. When it's not enabled and configured, it stays blue. So this was it about the equalizer. Last but not least, the REST API. So the REST API aims is targeting system integrators that want to take the control over any IPAC device using a secure and complete API. We exposed many features and functions over this API. REST means that we are using most of the verbs supported by the HTTP protocol and a message exchange format based on JSON to provide or modify internal configurations. There is an authentication mechanism that by default is using and requiring an API key in order to change and to enter to access this API. As we have done for all the other features, let me show you a bit more in detail, but for this I need to change my view to Postman. So Postman is one of the, I think, mostly used software for testing APIs. And as you can see on the screen right now, this is the collection made for IPAC, for the API audio client. We have several commands that can be used to fetch or push configurations. Let's see each one of them. So we have the possibility to get the version, and Postman is very useful because anything you do will be displayed immediately on the screen. For example, this get call is addressing my TPA400 device, which has this IP address, and this is the port number being used by the API. When I send the call, I get back a response from the device. In this case, it is a get version, so I'm getting back the version of the firmware. Same applies for the volume. So when I send this call, I can get back the volume, the master volume configuration. I can set the volume. In this case, I need to send this JSON in the body of the call. And when I do this, I can change the volume and the device replies with a 200, okay. And I can also see the body being resolved, okay. We have the mute function. We can get the sonic IP configuration, set the sonic IP configuration. We can reset to defaults a device with this call. We can reboot a device. We can get system status information. And this is very useful because you can get pretty much all the informations about the network, the licenses, and the device information. Or we may want to restrict the call only to the network settings. And in this case, the device replies only with the network settings. Our commands include more specific API commands to handle sources. For example, the get audio sources command, where you can fetch the full configuration in a JSON file of the sources. We can set all the sources in two ways from the API. The first one is by using a JSON file that is being passed into the API call, or the other one is by passing the configuration data as a JSON into the call itself, like in this example right here. We can enable or disable a specific audio source. We can set a specific audio source volume. We can get the status of an audio source. So, and sorry, not of an audio source, but of all the sources. And we can see in this moment, my device is playing the scheduler source, and it is monitoring Barix radio on the priority number 5. So Barix radio will not play until my scheduler it is playing. And at the moment it is playing What Lovers Do, I think from Maroon 5, from the playlist. We can get the list of audio files currently stored on the unit. And this is useful the moment we want to trigger the playback of an audio file, because I need to pass here which audio file I want to play, the source ID where the local file source is configured, and the volume of the file. This is optional, it doesn't have to be here, but if we want to play a file at maximum volume, this is needed. We can even upload an audio file from an API, and just like it happened for the set of audio sources using a JSON file, here we can pass directly into the call of the API the audio file itself. Or we can delete an audio file, specifying the file name that we want to delete and remove. We can trigger the playback, as we saw. We can stop the playback of an audio file, and we can get the status of an audio file playing. This is very much targeting specific use cases where you have a local file source and you want constant activity monitoring on the audio files that are currently playing or not playing. These are basically all the calls implemented into the API. The API is, let me just switch off Postman now and going back to the slides. The API is very well documented in our help.barix.com under the Extremer for XX section. Here you have all the documentation understood by any developer that wants to start playing around with the API. So it's a very important document to read whenever you need more information or you want to start developing your own applications around the IPAC API. Good. So this closes basically the discussion about the new features that we added into version 2.9 of the firmware. And I want to bring the discussion back a bit into the use cases where IPAC is mostly useful. And the main ones you can see right now on the screen are exactly for retail applications. Now with the schedule of advertisements and announcements, it is even a bigger asset, an IPAC device, into a retail store, into education for school paging to be used as a school paging endpoint. By the way, we recently also introduced in the market the paging gateway, and IPAC ties very well with the paging gateway, which allows you to page from any web browser, also from your smartphone. And it is a very nice solution. With the fixed time announcements, you have a bell scheduler, a powerful bell scheduler, and we still have the two most famous mass emergency notification platforms integrated into the unit, Informacast and Synapse. Just a reminder, Informacast requires its own license in order to run. Then we have telecommunication use cases where we can feed music on hold systems. The RTP forwarding in this case can be very useful. Maybe you want to feed a multi-source approach into a music on hold solution. We have already done this in the past, and we can still do this with IPAC today. Governmental agencies, stations alarming, or training center announcements. Again, with all the sources that we have available in IPAC, you can cover all these cases at easy. Transportation. The new API makes it quite easy to integrate with passenger information systems, known as PIS. And this integration can be adopted either on board or in stations, according to the passenger information system you are integrating with. Especially the section of the API useful to play announcements from local files. This can be controlled totally from a passenger information solution. Or hospitality. where you have the needs very much similar to what we have for retail, for background music, paging, announcements, so scheduler, HTTP streams, or other form of paging that we as Barix can offer. A reminder, simple paging or IC paging are also supported in IPAC. Where to find information? All the information about IPAC are found at this link, the one I just also showed you in the API section. So user manuals, API documentation, you can find also firmware release notes and firmware download in order to update your devices. You know that we as Barix are very skilled when it comes to customized projects. We have a great engineering team. These are just examples, the ones that you see on screen, in order to implement our devices into custom systems from different clients worldwide. We have many more. So please, if you have an inquiry about this, or if you need to engineer hardware and software for a specific customized solution, maybe IPAC can be the trigger of it. So it's also good to use IPAC in that sense. But then if you have a custom solution, just talk to us and contact us at presales@barix.com. And I want to close this webinar with these 3 main points and key points for you to take away. Why you should choose IPAC and why you should propose IPAC to your customers. Well, it is feature rich. We saw that it allows and it enables a wide variety of ways to achieve different applications. Example for paging, either using simple paging, IC paging, or pure RTP. For background music, whoever is using an HTTP stream, a scheduled playlist now, USB, or any RTP source from an in-streamer maybe. For emergency notifications, as I said, we support the integration with the 2 most famous platforms there, Single Wires in Informacast and Intrado Synapse Revolution. But also we can integrate with Barionet devices. So when you need an alarming solution that can be connected to a fire alarm panel and you want the input on Barionet to trigger a playback of an alarm on an IPAC device, this is also supported. And we support, of course, the integration into SIP infrastructures using the latest and most recent standards in terms of security, secure SIP and secure RTP. This brings me to the second topic, to the second item here, the flexibility. So all this future richness of functionalities allow us to be very flexible under configuration perspective. And at the same time, using the new API, we are also flexible under an integration perspective with third-party systems and appliances. The third point is that this product is continuously improved and supported. We strive to deliver new products that will be supported for the next 15 years. And many of you probably know the success of the predecessor of IPAC, the streaming client. And it is one of those products that after 15 years, it continuously gets success back, feedback from the market. So we want to achieve the same for IP audio client. And with these 3 points, I want to close and get into the Q&A section.